In this video, I'll be demonstrating how to use this tool which is available on ADA Playground for synthesis purpose. So let us understand the things that are required. Obviously, we need design that we want to synthesize. In this case, I have taken here full adder just for demonstration purpose. This is our full adder description here. And we need standard cells library. So this is the standard cell library. This is not for fabrication purposes. This is only for demo. So we have here in this standard cell libraries, we have one buffer cell, one NOT cell, and NAND cell, NOR cell, D flip-flop, and this is another D flip-flop. So with different features. So this is our standard cell library. And here we have, this is a script file. What it does, this script file is, it first reads the standard cell library. That is the command here. Read underscore liberty is the command to read this lib file. .lib stands for, this lib stands for liberty. So which is the extension for standard cells library. So that's the command that to read here, read underscore liberty space hyphen lib space standard cell library name. In our case, cmos underscore cells.lib. Next, second line is read underscore verilog. And this is our design.sv file, this design file name. And this is no latches. We'll discuss this in some other video. If you don't keep here, also not an issue for this example. And then this is the command here, synth, for mapping netlist to standard cells. This is the command, synth space hyphen top, the top module name, because this module may have submodules also instantiated in it. So in that case, the top module name is required. So that is how this one. So then this synthesis command is to just to generate generic netlist, not for the standard cell, not to map to the standard cells. What it does is it generates a generic netlist, meaning what we can infer from this, we can infer from this XOR gates, and we can infer from this AND gate and OR gate. That's what the generic means. And whereas this ABC tool, what it does is it maps this generated netlist to this technology. In this case, this is a demo technology, you can call it. It may be like 180 nanometer, 90 nanometer, like that. So to this technology, who maps? This ABC tool maps. And then intermediate, while doing this, some intermediate file may be generated. So for that, this is the clean command, and this is the flatten command. So this is required to, instead of having like submodules, the entire design is mapped, translated to single unit. So elaboratively, I will take in some other video this one. And then this write underscore verilog. This command is required to write the netlist file. And this command is required to report the cells that this design has got after synthesis, and then rough chip idea, like how chip area. So that is this is actually basically we are giving the name here fa.rpt, and this is the required command here. This one is required thing, and this is the required thing, and this entire thing is required thing. This is the user defined. Like I just gave name. You can give anything here. Like how many cells it is going to consume this design, that information, and roughly estimated chip area. So that report we will get from this command. So this is the script file. Okay. So before doing the synthesis, we have to ensure that our design is working correctly. So for that, we have a test bench. Since this video is not about to explain the test bench or explain this design file, it is the purpose of this video is to demonstrate this script. I mean, how we can use this tool, EDA Playground tool, for synthesis purpose using open source synthesis tool called EOSys. So what is that? Let us again summarize quickly. We have to have design file, and we have to have this script file and standard cell library. These three things are required to do the synthesis using EOSys tool. Here you can see this is the EOSys tool. And before doing this synthesis, we have to ensure that this design itself is correct. For that, we have to have test bench, and we have to select here among the available. Here there are commercial tools here. For that special, Gmail, Yahoo, these IDs are not going to work. Like some company name, like user at abc.com, like that. If those IDs are there, with that, if you're creating your account in EDA Playground, then you can use them. Otherwise, we have to use this free simulators and freely available tools, means this EOSys and this VTR tool for synthesis purpose. I did not try this Altec and Mentor Precision with Gmail ID. I don't know whether, available or not. Okay. But in this video, where I'm going to demonstrate this EOSys tool. So before, as I said, doing synthesis, we have to ensure that this design itself is correct. So for that, we have to select a simulator. So iCaras Verilog is a free simulator. Let us select that one. And then here, this open EP wave after run. So in waveform, if you want to see, then only you can select this one. No, if you don't want waveform, only the console, if it is displaying, that is enough, means in that case, that is not required. This thing is not required. Only this command here, system task here, Verilog system task will do this job, displaying the result in the console window. So let's select this one. Anyway, it is there. It will come here in the console. This because of this dollar monitor, we can see in the console. Let us select this open EP wave after run. So what is that? To run the simulation, we have to do, we have to have a test bench, and then we have to select a simulator, and then we have to select open EP wave after run if you want to see in the waveform. So after selecting all that, just run this one. So we will see waveform here. You can click here, and this vertical line that we see is a marker kind of thing. Like you can drag here, anywhere, like you just click and it will come there. So corresponding to this time interval, these are the values that we see. So like that, in the waveform, we can analyze. The other thing is, as I said, because of this dollar monitor in the console, we will get, here we are getting in the console the results. So having gone through these results here, we can say that yes, this design is meeting our functionality requirement. Now we are ready to go for the synthesis. So to do the synthesis, as I said, we had to have standard cell library, and we had to have this script. Then you select here Yosis tool, and then this is not this is required. Run.ys is required because this is the file that we have to run. This is the script file, and show diagram after run. So if you select this one, netlist, I mean that synthesized after synthesis, how circuit looks like that we can see here if you select this one. So after selecting that, you just run. Let us summarize before running quickly. To synthesize, we have to select the synthesizer here. The synthesizer here is this uses tool. And then we have to select this use run.ys. For that, we have to have this run.ys file here. This is a script file. And show diagram after run needs to be selected if you want to see the netlist diagram. So let us run. So this is the netlist, diagram that we can see here. You have this A input here, B input here, C input ABC, and our sum and CO is here. So this one we can close here. If you want to see, as I said, this will report, estimated chip area after synthesis. So to get that one, what we have to do here is you just uncheck this one, show diagram, download files after run. Just select this one. Again, rerun this one. So it will give us some result.zip file, so that you have to save on your desktop or somewhere. In my case, on desktop PDF playground folder, save it. So this is getting downloaded here. So once that is done, go to this show in folder. Here it is. Just right click and unzip that one. So this is the folder that we have downloaded, the contents of that folder. We are interested in seeing two things here. One is this report and netlist file. So this report I am opening. You can see here the number of cells are 14, and among the cells we have NAND gate number 8, NOR gate 2, and NOT gate 4. And the estimated chip area for that module is 52. And the units are depending upon our technology. If it is there in it's nanometer, 52 nanometers. That way, the units are applicable. And then another here is this netlist file. So if you open this netlist file, you will have standard cells here. Now you don't have this one. If you see this, your code, this code is entirely translated to standard cells. You see them here, those like in a image format you have seen, the same thing in text format like this. So this is called netlist file. Okay. So that's how you can use this EDA playground for synthesis purpose as well. So remember the things that are required quickly. Let us summarize. You can have design file. You must have the design file, and then script file and standard cell library. And then with using this open source Yosis synthesizer, we can do our synthesis using EDA playground. Thank you. If you have any doubts, please ask in the comments section. Thanks.